Welcome to Chapter 2 of our Predictive Analytics course, focusing on the general project workflow and the critical step of data preprocessing. This video provides a comprehensive guide to the predictive analytics workflow and preprocessing standards. Predictive analytics detects patterns in data to foretell future events, transforming historical data into reliable statistical models. Success in machine learning is process-dependent. We follow an 8-step learning path, moving from problem definition and data collection to the core steps of data preprocessing and model selection, before concluding with training, tuning, and deployment. Step 1 is defining the predictive goal. This is based on supervised learning, where the input is a labeled dataset. You must choose between classification, predicting a category, or regression, predicting a specific quantity. This choice determines your later evaluation metric. Steps 2 and 3 involve data collection and exploratory data analysis, or EDA. Collection gathers historical data, forming the model's bedrock. EDA is a detailed examination, summarizing the dataset and exploring underlying patterns before modeling begins. This is where unsupervised learning comes into play if you lack labeled data. Step 4a is data cleaning. Real-world data is rarely model-ready and requires handling imperfections like missing values. Depending on the dataset size, we can use deletion or imputation, which fills gaps using statistical averages. Step 4b emphasizes why feature scaling is non-negotiable. Datasets often contain features with vastly different magnitudes. Without scaling, algorithms that calculate distance between data points, like k-nearest neighbors, will be biased, distorting the distance calculation. Step 4c is mastering standardization and normalization. Standardization, or z-score, rescales data to have a mean of 0 and a standard deviation of 1. Normalization, or min-max scaling, rescales data to a fixed range, typically between 0 and 1. Scaling ensures that algorithms like gradient descent update smoothly. Step 4d is label encoding for categorical data. Machine learning models require numerical input. Categorical text data must be converted into a mathematical format, often through one-hot encoding. This creates a new binary column for each category, though it increases dimensionality. Step 5 is selecting the right model architecture. Classification tools include k-nearest neighbors and decision trees. Regression tools include linear and polynomial regression. The selection depends on the problem definition from Step 1 and the data structure. A spotlight on k-nearest neighbors, or KNN. The mechanism uses feature similarity to predict values, assuming that similar things are in close proximity. The process involves calculating the distance between the query point and training data and assigning the most frequent class. Decision trees are easy to interpret white box models. XGBoost, or extreme gradient boosting, is an optimized implementation of gradient-boosted decision trees. It uses regularization to penalize complex models and prevent overfitting, offering efficient performance. Steps 6 and 7 cover training and hyperparameter tuning. Training allows the model to learn the mapping function from inputs to outputs using the training set. Tuning involves adjusting hyperparameters, like max_depth, to control complexity and prevent overfitting. Step 8a focuses on evaluation metrics. For classification, we use accuracy. For regression, we use the root mean squared error, or RMSE. RMSE calculates the average magnitude of the error, keeping the error score in the same units as the predicted value. Step 8b is deployment and business intelligence. A deployed model transitions from analysis to predictive intelligence. Monitoring ensures the model stays relevant. Business applications include supply chain, maintenance, and marketing, using predictors to guide campaigns. Predictive modeling is a disciplined, continuous cycle from data to prediction. The quality of the prediction is determined in the preprocessing phase. Correctly handling missing values, scaling features, and encoding categories transforms raw noise into a valuable signal. Thank you for watching this video on the predictive analytics workflow and data preprocessing standards.